Dinosaurs may be the main attraction at the natural history museums. But around the corner from them, you can find the most amazing creatures that ever roamed the seas. Today, our guest will introduce Mosasaurs, our true sea monsters. Learn how they fit into creation and the flood, and why they aren't with us today. Coming up on today's edition of Origins, Monstrous Mosasaurs with Dr. Marcus Ross. Hello, my friends, and welcome to Origins. My name's Donn Chapman, and it's my privilege to be your host. During this program, we showcase interesting guests who present evidence from science, along with other important facts, validating the truth of creation and the accuracy of the Bible. Today's guest is no exception. Dr. Marcus Ross received his PhD in environmental science from the University of Rhode Island, where he researched all sorts of fossils, including a group of marine reptiles known as mosasaurs. In 2005, he started teaching geology, paleontology, and creation at Liberty University in Lynchburg, Virginia. He's greatly interested in the issues surrounding the creation-evolution debate and the intersection of geology with biblical events. Well, today I got a feeling we're swimming right into your sweet spot. Is that right?
Absolutely. Thanks for having me, Don.
Oh, it's so good to have you. Monstrous Mosasaurs.
That's right. Today we are going to look at some of the biggest, nastiest things that have ever swum the seas awesome. in the whole world. And I'm just going to hop right up to the screen here.
You go.
All right. So, Monstrous Mosasaurs. What are these sorts of things, and what is it that got me interested into them a little bit? So, my talk here is going to briefly cover three different areas. One, we're going to look at mosasaur biology. What were the creatures? Then we're going to look at them in terms of their fossil record in space and time, where are they found? And then we're going to start thinking a little bit about how their extinction relates to the flood. So just in thinking of how we're going to flow through here, we're going to start with mosasaur biology. So mosasaurs are fully marine squamates. And what a squamate is a science term for lizards. Basically, if you think for a moment of a Komodo dragon, and then you pop the arms and legs off of it and put flippers on it instead. It's a Lego one, it's okay, right? And you heave it out into the ocean. This is what it grows up to become. These animals were anywhere from about 10 feet long for the small ones.
The small ones are 10 feet?
The small ones are 10 feet long. So, you know, as long as the stage here, 10 feet long. The big ones were 54 feet in length.
Wow.
If you've seen the trailers for Jurassic World, there's this big creature that kind of rises up out of the water and grabs a shark, and that's a mosasaur. Now, in the movies, they make them big, because it's the movies, right? But 54 feet, still, you're talking about an animal whose skull is as long as I am tall. Now, these animals are lizards, they're not dinosaurs. When we think about dinosaurs, we're thinking about T-Rex and Triceratops and Apatosaurus. And anatomically, though, these ones are true lizards. They would have fit in the grouping with modern lizards. It's just that they lived in the oceans rather than on land. So we're going to take a look at a couple of the really interesting things about these critters, because it's a small family. There's about 30 genera. If you remember back to high school biology, we have genus and species. For us, it's Homo sapiens, it's our genus and species. So there's about 30 genera in these, and probably somewhere around 60 species that we've identified from the fossil record. Now, they're generalist predators, which means, you know, they kind of eat whatever. Here we've got an image by paleo artist Dan Varner of one of the mosasaur genera called Tylosaurus, going after this swimming bird. This bird actually is called Hesperornis. And it looks a bit like a penguin, but it's really an animal that would have stood about 3 feet tall, and it didn't really have arms. It had one little bone, the upper arm bone, that was it. It actually swam with big fins on its feet.
No wings.
No wings. So it kicked, and the feet had these really big pads on them to help push themselves through the water. Now, you know, this one's about to get, you know, a nice little, you know, McChicken sandwich sort of thing going on here, but these mosasaurs ate a lot of different sorts of creatures. They kind of didn't care what you were as long as you fit. You know, this is how big I am on the front end, so that anything smaller than that, fits inside. And the artist illustrated this animal on the basis of a fossil that was discovered in South Dakota. And that fossil in South Dakota had the remains of animals inside the stomach area of the fossil itself. So not only was the animal fossilized, it was fossilized with its last meals.
Wow.
Now, take a guess, say, pick a number between 1 and 5 as to how many different types of animals were found inside the stomach area.
1 and 5, the middle's 3.
The middle is 3. There were 3 and 2 more to make 5. I kind of cheat on that. There were 5 different types of animals that were found in the stomach area. There were some fish scales in there from 2 different types of fish scales, some vertebrae. There were shark teeth that were in the stomach area. There was this bird, Hesperornis, and there were also the remains of a different genus and species of mosasaur.
Yeah.
So this guy thought that cousins were fair game for the menu. It wasn't a cannibal. It didn't eat its own specific kind.
Anything that was alive that went through that mouth, he was going to eat it.
Yeah. And it's got a whole bunch of big teeth over here. What you can't see quite inside, there's also a bunch of little teeth on the palate of the animal. Huh. And those hook teeth kind of turn back so that, I mean, fish are slippery. You like to fish. And you got to hook them. And these teeth on the inside of the palate are there to make sure that anything that gets in the mouth stays in the mouth and goes the right direction. Yeah. So this animal here, Tylosaurus prorigor, typically somewhere around 20 to 25 feet, but there are specimens that get almost to 40 feet long for this animal. And it's really, really big. One of the things that we identify this as being different from the others is this snout. See how that sticks out pretty far from the teeth there? That's one of the things that helps us identify Tylosaurus compared to most other mosasaurs, which don't have a big part of their nostril, or kind of the front of their mouth that goes way out forward like that. Some of them were not generalist predators, though. Most of the mosasaurs would eat pretty much whatever was swimming by, but some of them were built a little bit differently. This is a skeleton and a reconstruction of a mosasaur called Plotosaurus. This one's known from California, out in the Moreno Formation, a group of deep water shales that are now up making mountains. And Plotosaurus was really long. You get a sense from this skeleton, it's kind of eel-like in shape. And Plotosaurus was about 25 feet long or so. And the tail, actually, we now know from new specimens, dips down this way. And so this older reconstruction, the earliest and the first description of this Plotosaurus by Camp in 1942, has the tail going straight, but we now know it actually goes down because the mosasaur would have had this fin, which is illustrated very nicely down here by Johan Lindgren's work. He's a Swedish paleontologist. And so we now know that Plotosaurus was really, the word we use in paleontology is tuniform. Right? When you think of a tuna fish, it's really streamlined, it's got a big tail, and they move fast. Plotosaurus was a very streamlined animal with a very big tail and likewise moved very quickly. It was probably a pursuit predator chasing schools of fish, where some of the other ones would just kind of come up from underneath, pull the great white shark type of approach.
Is this species as big as some of the others?
This is in the middle pack as far as the size of the mosasaurs go. But what's really interesting about Plotosaurus is this is the front flipper. And the front flipper has got, look at all those are all finger bones. Yeah. And you look and you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, about 13, 14 finger bones on each finger. We call this hyperphalange, lots of fingers. And that's all to turn that front limb into a really stiff oar, a stiff paddle. Okay. All the propulsion's happening with the tail. If you've ever watched a video where you're seeing a crocodile swim through the water, that tail goes back and forth, and the rest of the alligator pretty much stays straight. It's how the mosasaurs swam as well. But if you're going to be moving at high speeds, you need a strong paddle out front in order to help you change direction and handle the stress of the water when you want to move back and forth. And so Plotosaurus has got this really solid hand. Everything's tight, well put together to handle high speeds. It's a really neat kind of design view of this type of animal. Some of the other animals that we see as mosasaurs are specialized in terms of their teeth. Most of the teeth are simple cones. They might have some little ridges on the sides. But then you have a couple of ones like this one. This is one of my favorite mosasaurs, and I can say that because I like mosasaurs, right? Nobody would say, oh, favorite mosasaur, but Globidens. Globidens is known from North Africa. It's known from the United States and Alabama. It's known from South Dakota. It's got a good distribution. And Globidens is a shell-crushing mosasaur. It didn't go after fish. It ate beds of oysters and clams, big fat clams down at the bottom of the ocean.
Huh.
And we know that from two things. First, we expected that that was the case because its teeth are like ball bearings. They look like the back end of a ball peen hammer. And they're kind of this round things. They have a little nub that comes up, so it almost actually kind of looks like an onion. We refer to them as onion-shaped teeth. And so it would take those teeth and put a clam in between and just smash it down, break the shell apart. And then several years ago, a specimen was found also in South Dakota that had a whole big pile of crushed up shells in the stomach cavity.
Yeah.
And so what we're seeing with some of these mosasaurs is evidence for rapid burial, rapid deposition, because you don't get to preserve an animal complete and whole, especially something that might be, say, 18 feet for this globidens, without having to bury it very quickly to keep it away from scavengers, right? Keep it away from other animals that would eat it and tear it apart. Fast enough burial that you're able to preserve the last meals, for these sorts of things. One of globidens's cousins gave us a great bit of evidence for the fact that mosasaurs gave birth to their young live and out in the ocean. Now, when you think about a lizard and you think about how lizards have little baby lizards, you think of eggs most of the time.
Yeah.
Right? They're reptiles. But mosasaurs swam out in the ocean and they never once came back to land. They stayed out their entire life. And we know that from a fossil specimen that had the remains of 4 little baby mosasaurs inside the pelvic area of a female.
So it had eggs, but the eggs hatched when they were at sea.
Actually, what would happen is the eggs would stay inside the female's body cavity.
Right.
The shells would dissolve away, and the babies would stay in, attached to their yolk, until they were ready to be let out.
Isn't that amazing?
It is. It's a beautiful set of design. I mean, when we look at mosasaurs, we're seeing a snapshot of a picture of life at the flood. So when we think about those are quite a few components about the mosasaurs. These beautiful swimming marine reptiles, varied diets, different body forms depending on how they were approaching their life, and yet we see design throughout all of it. Now, next thing that we need to kind of think about is mosasaurs in terms of where we find them in the fossil record. So where are mosasaurs found? The easiest answer is the world, but the interesting answer is they are actually found everywhere. They're found on every single continent, including Antarctica, has given us fossils of mosasaurs. So where in the rock record? Well, when paleontologists think of the rock record, they think in terms of bottom to top, with old stuff down over here and younger material up towards the top. The Proterozoic is a group of rocks that typically doesn't have any sort of complex fossils to them. It's before we have animals. In fact, that's what the name Proterozoic means. It means before animal life. Then we have the Paleozoic, Mesozoic, and Cenozoic, and those are names that we might have been a little bit more familiar with if we read a dinosaur book or two when we were kids. At least some of these are rocks that were formed during the flood. Almost all creationists agree that Paleozoic and Mesozoic rocks belong in the flood. Some of them think that more or less of the Cenozoic belongs in the flood, but mosasaurs are found in Mesozoic rocks. They're found in rocks that are not at the beginning of the flood, but closer towards the end of the flood. In fact, they're not found in all the Mesozoic rocks. We break the Mesozoic into the Triassic, the Jurassic, and the Cretaceous, which are those dinosaur time periods according to the old Earth views, but these are mostly kind of periods of time in which things are being deposited during the flood. And we even break down the Cretaceous into a early and a late phase, and the mosasaurs are found in the latest part of the Cretaceous. They're found in Upper Cretaceous, which is the Mesozoic. They're found in pretty much the last parts of the flood deposits and rocks that are out there. And we got all these crazy names that I make my students memorize so that they can get a handle on some of this stuff. So what we've got here is recognizing that the mosasaurs are found in only certain types of rocks. They're only found in certain layers of the rocks. And now what we've got to do is kind of figure out if they start here and they end here, what's going on and why did they stop, in one particular area?
I think I'm glad they did, but
too.
we need to know the answer to why. But first we have to take a break. Don't you go away. This is fascinating, and we'll be right back. are back at Origins talking to Dr. Marcus Ross, and we've been talking about mosasaurs. And we did a little bit of the biology. We know they're lizards. We did a little bit of time and space, and the space seems to be about everywhere. But there aren't any around today, so we have to talk about extinction. What happened?
Noah's flood is certainly a component of that, but there might be some other things going on, which is where this story kind of takes an interesting twist. Now, to get back a little bit to where mosasaurs are found, it said, okay, they're found globally. This is a map that I put together about some of the major locations where mosasaur fossils have been discovered. And you can see there's a lot of dots in North America. There's a good number of dots in Europe, and that's mostly because those are the places where we spent a lot of time hunting and looking. There aren't as many dots in South America and Africa, but that's partly because there haven't been as many fossil expeditions.
Yeah, that could indicate where we've looked more than where they are, yeah.
Yeah, and you know, part of it is a bit of the geology, what, you know, what is exposed in the areas. And definitely North America has some of the best mosasaur localities in the world. And surprisingly, you know, it's places like New Jersey and Maryland that were the first ones, but the mosasaurs are most abundant in places like Alabama and, of all places, Kansas, which seem to be, you know, a little strange when you've got a 20, 30, or 50-foot long animal that you're finding this swimming ocean-going animal in some place like Kansas.
Yeah.
So for me as a paleontologist, as I was studying this for my PhD, part of it was to build a database of mosasaur specimens and, you know, map out all of their occurrences. But as a creationist going through the PhD program, I always had my mind, you know, kind of thinking, oh, there's a lot of mosasaurs in Kansas. There's a lot of mosasaurs in the Dakotas. There's mosasaurs in places like New Mexico and Colorado and Saskatchewan. You know, and that seems to point to a point in time when the world was covered with water. And that's exactly what the Bible tells us about, you know, what was going on during Noah's flood. How do you get animals like mosasaurs that live in the ocean, that are very obvious? They can't crawl around. They don't have arms and legs. They've got flippers. How do you put them in places like the Dakotas? How do you put them in places like Nebraska? You have to put the ocean on the land.
Incredible argument for a worldwide flood.
It is. Now, the secular geologists have their own mechanisms that they will put into place about how it is that you can get oceans over the continents, and the continents have to come down, and sea level rise has to happen, and things like that. But nonetheless, you know, those are the data. We've got fossils in certain places, and it's up to the creationists and the evolutionists to try and, you know, argue to the people. Now, what we're going to do with this is going to take a look at a couple of different places in the world. We're going to look at New Jersey and Maryland, which have some of the earliest records of mosasaurs as far as historically where we first found them in North America. And then we're going to look in Europe, where the very first mosasaurs were found in places like the Netherlands and Belgium, and take a look at how those groups of mosasaurs are similar and what's going on with this little explosion, right? We got this little blast mark down in Mexico, and that is a meteor that struck the Yucatan Peninsula. It's the same one that is used to argue why the dinosaurs went extinct on a conventional timescale. We're going to see how this plays in with the mosasaurs. So, I'm a northeastern kid. I grew up in Rhode Island, and I've spent a little bit of time in New Jersey, did some work there. This is an outcrop at a rock quarry. It's actually a phosphate mine, and they're quarrying this rock here, but it's not really rock. It's more of a granular sedimentary material. They actually use water cannons to blast it out and then screen it out. And right where that green line is the boundary between the Cretaceous, which geologists give the symbol K, comes from German Kreta, which means chalk. And above it is rocks that are assigned to another group of time in the conventional approach called the Paleogene, or PG. And that is the boundary where we see mosasaurs below it and no mosasaurs above it. And there's certain types of mosasaurs that are there. Not all the mosasaurs that we just looked at are found in New Jersey. There are some. Mosasaurus is there. Pliopodicarpus, the one that was giving live birth, that was there. There's some shell crushers similar to globidens. There's a variety of mosasaurs that are found in these rocks below. And no mosasaurs, at least no mosasaurs that we know are in place and haven't just been, you know, weathered and transported, redeposited sort of thing, are found in the rocks above. If you go out a little bit towards the coast from this area, geologists have drilled wells down into the ground there and extracted the rock from the core. And this is the actual location where the Cretaceous is in that rock area. You've got the Cretaceous here, and then you've got this weird layer of stuff going on, and above it is that Paleogene. And what's in this layer are some really weird things. There's a whole bunch of little tiny balls of rock, little tiny droplets of rocks. We call them spherules. They're kind of like molten glass, and they started off as being a spray material. It was actually so hot when this asteroid hit that it vaporized rock, and that vaporized rock material rained down from the sky and created this layer of little beads and balls. Above that is a bunch of clay, probably from a tsunami and some other weathering material, but also important is this spike, this blue spike here, represents a material called iridium. Now, iridium is one of those periodic table of the elements things that nobody learns about because it's so far down. It's not iron, it's not oxygen, it's not carbon. Iridium is very rare on the surface of the Earth, but it's abundant in meteors as well as in the Earth's mantle.
Oh.
So there's a question, how do you get a bunch of iridium on the crust rocks where it's not usually there? Was it volcanoes, maybe from the mantle blasting it out, or was it from a meteor? And it was the discovery of this iridium anomaly, this spike, that first led geologists in 1980 to postulate the idea that we were hit by a big meteor. It turns out that they're right because these little spherule beds and these other materials seem to be coming from the after effects of a big meteor strike. Now, if we go across the Atlantic Ocean, this is a scene, actually a picture I took by torchlight in a cave that was an old pillar and tunnel quarry in the Netherlands.
We're in the Netherlands. Okay.
We're in the Netherlands now, and we are looking at that exact same layer with the Cretaceous down below here, and the Paleogene is actually just above this. The only reason we could see this is because the roof of the cave had collapsed.
Oh.
So you think about that. You go into a room where the roof had collapsed and say, oh, let's go visit it.
And you went in there, yeah.
Yeah, we're a little crazy there. But what we see with these are the same materials. We've got those boundary clays up above. We have an iridium spike, which is happening in this weird contorted layer down here. There's also some burrows. Like this little thing here is a burrow from a shrimp that dug down. But when he did, he concentrated some of the iridium. That same mineral fell down with him into the burrow. And so we've got the same classic evidences as in New Jersey over in the Netherlands. Now the rocks are completely different. The rock below here, this is a chalk. It's made up of the pieces and little skeletal parts of lots of animals. It's not the sandy, granular material. So the rocks are very different, but they're capped by the same material, and these rocks in the Netherlands have the same mosasaur species in them as we do in New Jersey and Maryland. So what we find then is that we've got similar mosasaurs on both sides of the East Coast and Maastricht, the Netherlands. And above this layer of debris, there's no in-place mosasaurs. That is, there's no skeletal pieces. You might find an odd tooth, but it probably moved from one place to another. And the last appearance of the mosasaurs then is coincident with all of this impact-derived material. So the interesting possibility here, Don, is that mosasaur extinction might not be directly related to the flood. It's an event that happens while the flood is going on. So we tend to think of the flood as killing and destroying everything, and it certainly destroyed a lot of mosasaurs. But it makes you think that maybe there's something bigger going on with the flood. It's not just a whole bunch of water and sand and mud. The flood is cosmic. The entire world is under judgment. The entire world is being destroyed and decimated. So you see the
meteorites as a part of God's judgment?
They're happening.
Is there anything in the Bible, or is that just kind of your speculation?
No, that would just be, knowing what we have for a biblical framework and knowing from the rock record that we have
at the time and so forth.
It certainly does. I mean, he said, "I will blot out."
Yes.
And that is, when you think of a record, and you blot something out, you put ink over that so that you cannot see what was underneath. So the effects of the impact might be something like what we'd call a nuclear winter. When that impact hits, it sends dust up into the atmosphere, which blocks the sun, and that could kill off a whole bunch of the food chain. Because if a little fish needs microorganisms to eat, and a bigger fish needs a lot of little fish, and the mosasaur needs a lot of big fish, a small change in how much you've got at the base of the food chain rapidly ripples all the way up, and pretty soon big mosasaurs are actually not the top of the food chain anymore. They're the first ones to die out. So what this tells us for creation is that we've got a lot of other questions to ask. What other animals are affected by this? Is it just the marine? Is the terrestrial involved? Is this going on in the flood? Or what about post-flood extinction events? What does this tell us about how creationists can approach biostratigraphy, that is, tracing these animals up through the rock? A lot of work needs to be done, which means I need a lot of kids growing up learning about dinosaurs, learning about mosasaurs, so they can help come into this and bring their expertise into God's fold.
What a great lesson you had for us, and I love the facts. I also love the speculation that's going to keep us looking and learning and growing. You've done us a great service.
Thank you so much.
My friends, as you look at the handiwork of God, the things that He has made, its magnitude, its size, and how it isn't just the things on the land, but the sea is full of the handiwork of God. And then we see that suddenly something new is there and something old is gone. And there's always those why questions. But all of it's declaring a truth, and that is that God has made this world, and He's made us. It's His view that He created you, and that should always be your worldview too. Join us again soon here on Origins, and until then, God bless you, my friend.
Thank you for watching this edition of Origins. For a DVD of this series, you can order online or send a $12 donation to cover shipping and handling and write to Origins Program number 1612, Cornerstone Network, Wall, Pennsylvania 15148. If you like a copy of the PowerPoint information presented today, you can download an episode guide at originstv.org.
Origins is made possible by the faithful prayers and financial support of you, our Cornerstone family.